Okay, we are looking at section 10.4, inscribed angles. And yeah, that's what we're dealing with. Okay, an inscribed angle is a vertex. Your angle has a vertex on this circle and the arc that's intercepted by the angle. So we're dealing with this. Your vertex is right here. Maybe I should have a different color. Okay. Oh, look at that lovely tracing. Okay, so there is your angle right here, and notice your arc right there. That's considered the arc that's intercepted by the angle. Please note the corresponding arcs. This happens a lot in a lot of pictures. I have kids who ask me lots and lots of questions throughout this chapter about, oh my gosh, what is this, what is this arc right here? Well, look at there's angle B. That's an inscribed angle because its vertex is on the side of the circle. It's not a central angle. Well, here's the arc associated with that. If you check this out, here is angle C. I'm going to move the C right there. Oh, look at its arc. It's the same arc. And that happens quite often in a lot of our problems. So we kind of want you to be on your toes, be looking out for that. Because it can get, a lot of pictures, lines are overlapping, pictures are overlapping. We want to be aware that that happens quite often. An inscribed angle is half of the measure of the arc. So if you have a nice, that is not what I wanted. I thought I had circle set. All right, so there's your circle. If you have an inscribed angle, and this is, say, 40 degrees, then your arc is 80 degrees. So the inscribed angle is half of the arc measure. And vice versa, the angle, I don't want to say angle. I want to say the arc measure is equal to 2 times the inscribed angle. Okay, so you take 40 times 2, you get 80. If your arc is 80, then your inscribed angle is 40. If A is 70 degrees, find the value of B. So 70 degrees, that means this arc right here is 140 degrees. But I have to find B, and this is one of those cases. Look, 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 look. Trace along with probably not your pencil in your book or anything, maybe if you have a worksheet, or use your finger. Oh my gosh, exact same arc. So if your arc is 140, then your angle is half of that. Look at me, write down the wrong number. Half of that is 70. Okay, so angle B is 70 degrees. All right, if your intercepted arcs are congruent, as I'm marking here, then your angles are going to be congruent. So if you see congruent arcs, then you have congruent angles. They don't have to be necessarily in the exact same location. Okay, example 2, find the measures of the numbered angles. If arc UW, put that right here, is 20. Arc XY is 40. What in the world? That doesn't seem right, does it? Arc UZ, I must have a wrong number somewhere in here. Arc UZ is 108, and arc UW is equal to arc YZ. Okay, so this is congruent to YZ. Okay, so I'm going to put 20 right there right now, so I already know. Okay, find the measures of all the numbered angles. So here we go. We've got 1 right here. Well, if the arc is 20, then the angle has to be half of that. Why do I keep writing down the wrong number? I'm thinking 20, but I need to write half of that, which is 10. So I got angle 1 is 10 degrees. Let's see, angle 2. Well, here we got 40 for the arc, so now the angle has to be half of that, which is 20 degrees. Angle 3 is right here, and I've got 108 for this arc. There's my angle, there's my arc, so half of that is 54 degrees. Angle 4. We're going to come back to angle 4 here in a little bit. And angle 5 is this angle right here. So there's angle 5. I have this piece, the red, all the way over. So that is still also going to be 54 degrees as well. Okay, now let's see if we can figure out angle 4. I see a triangle. I'm going to highlight that triangle. Whoops, whoops, whoops. Come back here. I'm going to highlight this triangle right here. A triangle has to have 180 degrees. So notice how the rest of math is never going to leave us. 180 minus 20 is 160, and then I minus this 54, and now I have 116. Nope, 106. So this angle 4 should be 106 degrees. Okay, moving on. A semicircle. A semicircle is half your circle. Okay, so we kind of got this piece right here. So my arc for this angle right here, this is my arc. Well, half of 180 degrees is 90 degrees. So anytime you know that you're dealing with semicircles, you are now dealing with right angles for your inscribed angles, because this is 180 degrees if it's a semicircle. Okay, your inscribed angle is half of that, so your inscribed angle in this case is going to be 90 degrees. All right, so there's a picture with my funky looking 90-degree markings. Triangle TVU and TSU are inscribed, so they're inside a circle P with arc VU congruent to RS. So arc VU is congruent to SU. Okay, so those two are the same. Find the measure of each numbered angle if angle 2 is x plus 9 and angle 4 is 2x plus 6. Okay, so these are congruent to each other, which means this angle is congruent to this angle. Okay, angle 2 plus angle 4 plus this 90 degrees has to add up to a triangle which has 180 degrees in it. So x plus 9 plus 2x plus 6 plus 90 equals 180 degrees. So we have 3x plus 15 plus 90 equals 180. I should probably add those together, but in my mind, I'm doing a weird solving there. That was kind of a bad example. So if you add those together, you get 105. If I take away 105 from 180, then I get 75. So let's just go down to there. Okay, and then I get divided by 3, I get 25. So my x value is 25, so I go back and put it in. 25 plus 9 is 34, so angle 2 is 34. Angle 4 is 50 plus 6, which is 56. So if angle 2 is 34, then angle 4 has to be 56. I double check, that adds up to 180. Angle 2 is congruent to angle 1, which is 34 degrees. Oh my gosh, angle 3 also has to be 56 degrees. And we have now found the measure of each numbered angle. Quadrilateral. Notice I have a quadrilateral, a four-sided figure, inscribed in my circle. Or you can say your circle is circumscribed about the quadrilateral. What you need to know is that opposite angles of the quadrilateral are supplementary. Supplementary means they add to 180 degrees. Okay, so angle A plus angle B equals 180 degrees. And same with C and D. They add up to 180 degrees. So quadrilateral QRST is inscribed in circle M. Probably means I should have a little dot with an M here. If the measure of angle Q, I think that's supposed to say 87. If you don't believe me, there it is. Okay, so that's 87 degrees. So I'm going to put that right in there, 87. Write that back out. Angle R is 102. Find the measure of angle S and angle T. So I need to find angle S, find angle T. Well, this angle plus this angle have to add up to 180. So I subtract 180 from both sides, or 180, excuse me, subtract 87 from both sides, I should have 93 degrees. So this is going to be 93 degrees. This side and this side have to add up to 102, or add up to 180. So 102 plus, I'm going to call this y, equals 180. So I subtract 102 from both sides, I get 78 degrees. So this is going to be 78 degrees. Yep. And of course, we'll have to use that information to do other problems. And that ends this lesson.